All right, good morning, everybody. So I'm not here. Every now and then I have to have a doctor's appointment, and once a year they want to check on me and make sure I'm healthy and okay. So I'll see you tomorrow, but let's go through this, okay? So today's date, December 6th, and today what we're going to do is we're going to be finding angles from the unit circle, okay? We're going to be finding the angles. All right, so grab your unit circle, please. Grab your unit circle, okay? So if I take a look at my unit circle, these are the angles. So these are the answers. Pi 6 would be an answer. 120 degrees is an answer. 240 degrees might be an answer. Negative 45 degrees might be an answer. I don't know, 5 pi 6. So these, my answers, are the angles. How do we get these angles? Well, it depends on the coordinate that's with them. So if I have a y value of 1/2, it goes with those angles. If I have an x value of, say, negative 1/2, it goes with 2 pi thirds. So how do we do this? Well, let's take a look at our example, okay? And again, Kai is going to say we always want the one closest to the origin because, you know, if we take a look at the unit circle, and you want to get here, look right there, right there. You want to get there? Do you go all the way around? Heck no. Or do you just go back to it and do a negative angle? Okay, remember that. The shortest distance from 0. One answer, always closest to the origin, okay? All right, so example 1, sine inverse. So when you see this symbol, when you see that symbol, it means find the angle. And you know that from your calculator. So find the angle. When you see that symbol, sine inverse, it's doing, saying the inverse operation. So let's find a y value. So let's find a y value of 1/2. And it occurs twice on the unit circle. It really does. 1/2 for y value happens here. And let's do ours in degrees for a while, and then we'll do it in radians, okay? So it happens, here's a 1/2 y value, and here's a 1/2 y value. So both angles are correct, 30 degrees or 50, but 30 is closer to the origin, so theta is 30 degrees. If we did it in radians, we'd say theta is pi 6, okay? All right, hopefully you got that. Okay, find the angle. Cosine is the x value. Negative 1/2. And again, there's going to be two answers. Okay, negative 1/2 for a x value is here at 120 degrees. Negative 1/2 for an x value. And here at 240 degrees. But hopefully everybody recognizes that the closest distance is the 120. So we're going to say theta equals 120 degrees, or in radians, theta is 2 pi thirds. Depends if radians or degrees. I'm just going to give you both. Why not? Now arc, tangent. It's the exact same symbol as this, tan inverse. This arc really refers to the fact that we really are finding the length of the arc. These, even that pi force, so now in this case we've got to do radians because that pi force is an answer in terms of length. So we do definitely need this one to be in radians. So where's tangent 1? It's here. Tangent is 1 here. And tangent is 1 here. So either we're going to go to pi force or have an arc length all the way around here to 5 pi force. No, too far to go. We want the shortest one, the one closest to the origin. So we're going to go with pi force. So the arc length is pi force. All right. Arc cosine. So again, the same thing. Looking for the arc length or cosine inverse of 0. We're going to have to do it in radians because we're looking for an arc length. Okay, so x value, right? X value, cosine to an x value. So let's find an x value of 0, and that occurs here at pi halves or here at 3 pi halves. Well, obviously pi halves is the shorter arc length, so we'll go with pi halves for my arc length. Okay, hopefully this is making sense. I hope so. Okay, now sine inverse. This is a little bit tricky, but if we're smart, we can get it. So we're looking for a y value of negative 1/2. A y value of negative 1/2. So It is negative 1/2 is in two places. It's here at 7 pi 6. Oh, we'll do degrees first. Here at 210. Or it's here at 330. Now, both of those are a long ways to run, right, Kai? Wouldn't it be easier just to run backwards? So instead of going to 330 degrees, let's go backwards to negative 30. So I'm going to say theta is going to be negative 30 degrees, or in radians, it's a negative pi 6. Closest to the origin. Go backwards. There it is. Don't go all the way around. That'd be silly. Just go right to it, okay? Tangent values are on the outside of my circle in pink. We did that on Friday. I'm looking for a negative 3. Square root of negative 3. Square root of negative 3 can be found in two places. Here, down here at 300 degrees, or here at 240. But the same thing. Let's not run all the way around here. We just run backwards. Run backwards. So let's call that, instead of 300 degrees, let's call it a negative 60 degrees. So theta is negative 60 degrees, or in radians, it's going to be negative pi thirds. Okay, if I get going too fast, ask the substitute to pause it, and you guys can catch up, okay? I'm hoping I'm not going too fast. Cosine, okay, x value. Okay, x value. So I'm looking for negative square root of 2 over 2. Cosine is my x values. Negative square root of 2 over 2 is here. And it's also here, negative square root of 2 over 2 for x value. So it's either 3 pi fourths or 5 pi fourths. Obviously, 3 pi fourths is closest to the origin, so we're going to go with 3 pi fourths. Or I guess in degrees, we can say it's also the same thing as 135 degrees. We'll take both. It doesn't really matter to me. I like radians better. Okay. Tangent, negative 1. So tangent, again, is on my outside values. On Friday, we already evaluated the tangents. It's the y over the x. So we put those down already on our circle. If you weren't here Friday, you probably need to get a copy of this. So tangent equals negative 1. There, at 315 degrees. And way up here at 135 degrees. But, you know, we could run all the way around, or we could run backwards. Let's just run backwards. Let's go to negative 45 degrees to get there. Let's go negative 45 degrees. So theta is going to be negative 45 degrees, or in radians, negative pi fourths. Okay? I like both answers. Okay. Sine inverse. Okay, we're looking for, oh, that should say sine inverse. No, not really, because we're looking for the angle. Sine of the angle equals negative square root of 3 over 2. Y value, and it's found here and here. Either 300 degrees, 240 degrees, or let's just go backwards to it. How about negative 60 degrees? Or we're going to go and call that negative pi thirds in terms of radians. Okay, hopefully this makes sense. Now, example 2, the cofunction is a little bit different because we don't have them in the circle. But to do the cofunctions, let's go back to what we have. Okay, what we have is really 1 out of 1. We want some angle, but let's do it in sine. So we've got cosecant theta is equal to 2. That's what it really says. We're looking for the angle, a cosecant angle that equals 2. All right, well, we know that we can't find cosecant on our circle. We can find sine. So I'm going to change this to 1 over sine. Okay, that's the easiest way to do it. So now 1 over sine, we'll flip it. Okay, so I'll change it to sine of theta equals 1 over 2. Okay, so now I'm looking for a y value of 1/2. Y value of 1/2. Go to my unit circle. Y value of 1/2 is here at 30 degrees, or here at 150. But obviously 30 is closer, so we take the 30 degrees. So theta is equal to 30 degrees, or in radians, pi 6. Okay, let's do B. Okay, cotangent. Well, cotangent is not in the unit circle, but it really says that the cotangent of some angle is equal to the square root of 3. Okay. Well, that's the same thing as 1 over the tangent value is equal to the square root of 3. Well, I don't want 1 over tangent. I don't want 1 over tangent. I want to flip them both. So I really want tangent of theta equals 1 over the square root of 3. But That's not a very good answer, so if I rationalize the square, that's what Lauren said the other day, rationalize the denominator, so I really get tangent of theta is equal to, let's see, that's a square root of 3 over square root of 9, which is 3. Ah, that's on my circle. Sure is. I believe that's at 30 degrees. There, at 30 degrees. Well, it's also way over here at 210, but we're not going there. We're going the shortest distance. So we're going to go to 30 degrees or pi thirds, or pi 6 as a radian. Okay? All right, secant. Same thing with secant. So secant, it's the same thing as saying, let me squeeze this like this. Secant of some angle is equal to negative square root of 2. All right, well, we don't have secant on our unit circle, but we do have cosine. So let's change it to 1 over cosine of theta is equal to negative square root of 2. Again, I don't want 1 over cosine. I do not want 1 over cosine, so let's flip it and make it cosine of theta is equal to 1 over negative square root of 2. But I need to rationalize that. Oh, that's funny. Sorry. Double square root. Rationalize it. Square root of 2, square root of 2 of cosine of theta is equal to, see, that's the square root of 2 over negative square root of 4, which is a 2. Negative square root of 2 over 2. Let's see, that's somewhere on the unit circle. I'm pretty sure it is there for next value, because cosine of 135 degrees, or there, cosine x value at 225, but 235 is closer, so we're going to go with 135 degrees. So theta equals 135 degrees, which is same as in radians. That's my 3 pi fourths. Got it? Okay, turn the page. Hopefully I'm not going too fast. If I go too fast, please ask the substitute to pause it if you need to catch up, okay? Try not to go too fast. You're not here. Okay, turn the page. All right, now, you can use a calculator to get these. We just have to be careful of the mode, right? Now it says find the angle in radians. Okay, so sine. So again, what we have to do is change our mode to, in this example, radians, right? Angle in radians. So change my mode. Go to my mode. Change my mode into radians. Okay, it's in radians. I want the angle, so what I'm really going to find is the sine inverse of 0.8. And I'm going to go sine inverse of 0.8. And I get an answer about 0.93. Okay, what does that mean? Well, I like to show you what this means because it's kind of cool for me. If I take a look at our circle, and you have 0.8 for a y value, that's a y value. 0.8 might be about there. What angle do you have? You have a 0.93 angle, okay? Cosine inverse of negative 0.55. So again, I'm just going to cosine inverse of a negative 0.55. I'm going to answer about 2.15. Okay, again, I like you to know what this means. Cosine is the x value. So if I have an x value of negative 0.55, here's my negative 1. I'm going to go back. Negative 0.55 might be about there. What angle? That's about a 2.15 angle. Remember, that angle there's 3.14, right? So 2.15 is that angle or that arc length. Okay, I already know this is an error. I know this is an error. I know it's an error because y value of 1 is right there on my unit circle. I can't go beyond that, but check it out in your calculator anyway. Clear. If I go sine inverse of 1.2, error, it has to be. This is not possible. If I look at my unit circle, right, I've got a y value of 1. 1.2 is out here, no man's zone, so there's no solution. Okay? Now, D, how do you do this with cofunctions? Well, let's do what we did on the other side. Let's change it into sine, cosine, or tangent. Because you don't have a cosecant button. You really don't. You do not have a cosecant button. You don't have a secant button. You don't have a cotangent button. But what we can do let's rewrite this. We've got cosecant of some angle, right? We're looking for an angle because that's what that says. Find the angle. Find the angle. So we're looking for cosecant theta of some angle equals 1.5. Well, that's the same thing as 1 over sine of theta equals 1.5, right? Flip it. So I'm looking for sine of theta equals 1 over 1.5. And if I want the angle, I'm going to rewrite this as sine inverse of 1 over 1.5, right? Isn't that how I do it? If I want to find the angle, you find the sine inverse. Okay, now I can do that. So I'm going to go ahead and use my calculator. I'm going to go sine inverse, oops, wrong button, sine inverse of 1 divided by 0.5, and I get an answer of about 0.73. So my angle, theta, is about 0.73 radians, right? Radians, or an arc length. Same thing with E. Instead of having it in terms of secant, let's change it to cosine, because it's really secant of some angle equals 2, but you're not going to find that on your calculator or in the unit circle. You're not going to find secant, but you will find cosine, because secant's 1 over cosine. I flip it. Cosine of theta equals 1/2. Oh, that's on the unit circle. I don't need a calculator for that. That's on the unit circle. 1/2 for cosine's right there. Pi thirds. Now I could use my calculator and I'll get the decimal equivalent of that. All right, if I went cosine inverse of 1/2, all right, cosine inverse of 1/2, and that's pi thirds. That's pi thirds. Check it out. I like pi thirds better. Yeah, it's pi thirds, right? Same answer. Pi thirds is such a better answer, okay? Such a better answer. I'll take either one, but anyway. Okay, now, number 4. Find the exact answer. So this is not on the unit circle. So we're not on the unit circle. And Brittany will agree, if she's here, that you have to know how to do this for calculus. So what do? It says build a triangle. All right. Let's try and build a triangle. Okay. I'm going to draw a triangle on the xy plane, right? Because sines, cosines, and tangents all have x, y, and the radius values, okay? So I've got some angle. Tangent inverse of 2/3 is really going to be some angle, okay? I know tangent is the y over the x. So I know my y value's got to be 2 and my x value's got to be 3. Has to be, because that's what it says, right? Y over x. So I'm going to take my triangle and I'm going to put my y value 2 and my x value is 3. Okay, now what I don't know is my radius. I can find my radius. My radius, I know how to find that because I learned this x squared plus y squared equals r squared, which is Pythagorean's theorem. Thank you very much. Yes, it is. So I'm going to go, okay, 3 squared plus 2 squared equals r squared, right? 9 plus 4 equals r squared. 13 equals r squared, right? Square root of 13 equals r. Okay, square root of 13 is right there. All right, now let's find the cosine of it, because the original question says cosine of tangent inverse. Okay, cosine. Let's see, what do I know about cosine? Well, cosine of an angle is the x over the r. Well, I know that. My x value is 3, and my r value is square root of 13, so my answer is 3 over the square root of 13, which I would probably take, but a better answer is 3 square root of 13 over 13. That's a better answer. Okay, so use the unit circle for most of these. If it says use a calculator, then use your calculator. I'll see everybody tomorrow. Good luck, and I will see you tomorrow, okay?